Alright, so ladies and gentlemen, in this video I'm going to describe how to find the volume of circular solids. Specifically, I'm going to talk about the volume of a sphere. So I have a sphere drawn right here, and as you might suspect, we'll definitely need to know the radius in order to find the volume. Now in class you may or may not have discussed the derivation of this formula. In this video I will not be discussing the derivation of the formula, but feel free to check it out on YouTube, and there's some pretty cool ways to come up with this formula. Alright, so the volume of a sphere, so I wrote V sphere, is equal to 4/3 pi r cubed. Now to be clear, I could write this as 4 pi r cubed divided by 3. These things are, both of these equations are the exact same. So the volume of a sphere, it makes sense that you would need to know the radius. It makes sense that pi would be involved. It also makes sense that the radius should be cubed because we know in volume our units will be cubed. But the 4/3 is kind of a bit of a mystery. So in this video you just have to take our word for it. But again, feel free to either have a discussion in class or just go on YouTube and watch an interesting video on it. So that's a very, very important formula and idea, and keep in mind it would be provided on your MCAS formula sheet. Alright, so then you might say, well, okay, what about the volume of a hemisphere? Well, same idea. We'll need a radius. And what's nice is we don't have to be super careful like we were with surface area. Volume of a hemisphere would just be half the volume of a sphere. Let's do a little calculation here. What is half of 4/3? Multiply the numerator, multiply the denominator. That's 2/3. So the volume of a hemisphere will be 2/3 pi r cubed. Now this is not the kind of thing that would be on your MCAS formula sheet, so you'd have to reason that out. Okay, so these are the two crucial formulas or ideas, and in your mind I really just want you to know this one, and then just know that you can take half for the volume of a hemisphere. Alright, cool. So now in this example we're going to find the volume of this sphere. Now keep in mind I was annoying and I gave you that the diameter is 12 meters. So it's important for you to realize that that means that the radius is 6 meters. Okay, so we're going to find the volume. It always helps to write down the formula that you need to get started. We know the volume of a sphere is 4/3 pi r cubed. Okay, now all we need to do is just plug in a 6 for the radius. Okay, now if we were to use PEMDAS here, what we need to do is we need to figure out what 6 cubed is first, and that'll be 36 times 6, which is 216. And now don't worry about this 4/3. All it really means is multiply by 4 and divide by 3. So let's first try and divide by 3 because that'll make our answer smaller first, and then we'll multiply by 4. Well, 3 goes into 21 7 times, and it goes into 6 twice. So I know that 21 divided by 3 is 72, okay, and I still need to multiply by 4 and by pi. 4 times 70 is 280. 4 times 2 is 8, so we have 288. Don't forget to multiply by pi. And you can just write 288 pi. We understand that when we say 288 pi, we mean 288 times pi. And don't forget that our units will be cubed. That's the volume of my sphere. So now in this example, imagine that we're given the volume of a sphere, and the question is, what's the radius? Okay, well, what we can do now is we know the volume of a sphere is equal to 4/3 pi r cubed, but we also know that it's equal to the result they said, 36 pi. So our goal is to solve for the radius. We want to isolate the radius so that we can solve for it. So I might as well just divide both sides by pi, because pi divided by pi is 1, so I'll just have 36 on the right-hand side. 1 times 36 is 36. Similarly, the pi over pi, which is equal to 1, will cancel out from the left-hand side as well. Now if we want to isolate the radius, we're going to actually multiply by the reciprocal. That way I'll have 1 r cubed, otherwise known as r cubed. Okay, now I could multiply 36 by 3, or I could divide 36 by 4. I would rather say 36 divided by 4 is 9. Don't forget to multiply it by 3. So we know r cubed is 27. Now what we can do is we can take the cube root, which is the opposite of cubing, both sides, and that will just isolate our radius on the left. And then you have to ask yourself, what times itself again makes 27? And that number would be 3. So we know that the radius is 3 units big. So sometimes you'll work forwards and sometimes you'll work backwards. And this question is for you. So I've given you enough information, and my question to you is, what is the volume of, and I'm going to say these are millimeters. We'll do some like really small calculations here. Let's say this is a volume of like a capsule or a gel cap or something. I'd like to know the volume of the capsule. And you do have enough information. I'm telling you that this little thing right here, otherwise known as the radius, is 5 millimeters, and this height from top to bottom is 20 millimeters. So from there, can you figure out the volume of the capsule? Good luck and have fun.